Hi, and welcome to another part in the series of Java by example. Today we're going to look at sorting the list, because lists and sets are all extending the class collection and have all the functions of collections, and collections could be sorted. So that is the functionality we will look at today. And in order to make an object sortable, we need to make it comparable. So this animal should therefore implement comparable or comparable perhaps, and see here. That should be imported as well. Collection comparable, perhaps. See here. Yes. And in order for these to be comparable with each other, they need to have a function that defines what is compared. So in order to make this class comparable, it needs to have a compare to method. So you can take one object and say compare this with this other object. And at the moment we said it's only implementing the class comparable, and that means that it compares objects with objects. And in this case we know that we can't compare any object with any object, because we want to, in this case, we want to compare it by name, so we can sort all the list items by name. So in our case we are interested in only sorting animals, because animals has names. And to restrict our comparable class to animals, we say that this implements comparable of type animal. In that case, we need to implement a compare to function that takes an animal and compare it with the current animal. So let's do that. We create a public int, because all compare methods will return an integer value that is either -1 if it's this value should be this object should be before the object that it's compared to, or +1 if it should be after one that it's compared with, or 0 if they are equal and the order isn't defined. So let's see here. Then we should have compare to animal A. And in this case, we only want to return the value of this name compared to a name. And this is because in this case we have a compare to function on strings. So strings could be compared to other strings. And let's see here, the package collection does not exist. We see here if we could use collections, perhaps. No, is comparable a class that is already defined? Seems so. So we don't need to actually import that. So now we have made our classes comparable. So all the animals could be compared with other animals. And to sort these, because if we see the result here, we still have Fluffy, Sanders, Nelson, Fido, and that's not the right order if you look at how strings are ordered or how the alphabet is ordered. So in order to make this list sorted, we only have to say collections sort animal list. So there's a function on, see here, it should be on the base class of collections. See here, perhaps we need to import that one. We will Google for it. It's much easier to see. Let's see here, collections. Let's see what is actually collections util. Okay, so let's get back here. Util collections, and so then collections should be defined. And in this case, we see that we have sorted our list. First we have Fido that starts with an F, and the next letter is an I, and I comes before L, and so on. And so in this case, we have sorted the list by the string value of name. And in order to make this list sorted the other way around, I think we only could put minus value there. We might get the other way around. Yeah, we turn the list around, so we sorted it by Sanders first, and then Nelson, Fluffy, and Fido. So that's how it works. It just gives you a value which is either -1 if it should be before, if it's 0 they are equal, and if it's +1 then it comes later in the list, or it's larger than the element at the moment. So that's the way sort will work. So let's try another thing here. We could see if we have the cat here. Perhaps haven't tried this before, so this could be interesting. If we implement the compare to here, so this is an animal. So in this case, we compare animals still, and so that should be valid. Return super compare to A. So that shouldn't change anything, I think. Yes, that still works. But perhaps we could do like this. If the animal A is actually a cat, which is the same as this, we could try to sort the cats by hairballs. So that we could try. If A, let's see here, if in A instance of cat, then let's see here, then we take this hairballs per day. You see here, cat A balls per day. See here, if hairballs per day is larger than return -1, and if it's less than, return 1, or else return. Then we return this super where we compare all names and see what we get result here. Declaration of cat is not see here. See here, what are we missing? Compare to if a instance of perhaps of course not much of a large letter. Cannot find symbol hairballs per day. Because in this case it's still an animal. We need to say that A is a cat in this instance. Because we have checked if it's a cat, but we haven't actually casted it to a cat. Okay, so now we have actually made this change that we check the hairballs per day and try to sort them by hairballs per day, and in this case it gave the same result because we probably had the same sort order. If we change this around, we will get Nelson before Fluffy, because Nelson has more hairballs per day than Fluffy. So in this case we turn them around. That if it's larger than it should be before, and if it's smaller than this, it should be after. So it's maybe easier to see if we turn these around. So we put the cat at the end here. So if this is larger than the hairballs per day, then it should come before, and if this is less, then it should come after. So that's why they flip, why they are in a different order. And we could actually do the same with the dog, but we could come to a situation where we have a compare function that has multiple expressions inside of the compare function that contradict each other if we build a really complex compare to function. So you have to be aware that you can't put really complex logic into a compare to function that don't give the same result for every input, or that can't give two inputs that say that it should be before this but it should actually be after this, because then you will get a compilation error or a runtime error that says that this function doesn't have a strict contract that actually tells you in which order things should be. So that's how we add a compare to function to an actual Java object. But finally, there's one more way we could sort these lists, and that's by creating a new class. And we can try this out here. We can create public class wait compare, implement the interface of comparator, and this is a comparator of animals. And in a comparator, you are required to implement. So we first need to import the comparator. See here. So in this case, you need to implement the abstract function of compare that compares two different animals. And it's very similar to the earlier compare to function. The only difference is that this or the first animal that you check is the first that is sent into this function. So in this case, we will compare A with the animal B. So if A get weight is less than b, get weight, then it should be before in the list. And if a get weight is larger than b, get weight, then it should be after in the list. And if the weights are equal, then we say that we don't have any order on them. Let's see here, yeah, so that worked. Now the only thing we need to do now is to say for this sort function we will use this weight compare class to compare the different objects in this list. See here, cannot be referenced from a static context. Yeah, of course, this class needs to be static as well. And there you have it. Now we have a list of sorted animals on weight, where the animal that weighs the least comes first, and the animal that weighs the most comes last. And we kind of change the order of these, so we have them the other way around. And this is very handy if you require to have one default sort order for a specific class, and then you want them to be in some other sort order for a specific use. Then it's very nice to be able to create multiple sorting classes. And you could create these classes inside of the actual object, so you could fetch them from the object when you require a comparator. And I think that's what we will cover today. If you like this video, then please give it a like, and if you want more of this kind of content, please subscribe.